Welcome back, students. Let us recall what we have learned in the previous class. We have learned about motion and its types, relation between speed, distance and time, and measurement of time. Now, let us discuss about uniform and non-uniform motion. A body is said to be in uniform motion if it travels equal distance in equal interval of time, whereas a body is said to be in non-uniform motion if it travels unequal distances in equal interval of time. For example, consider a car moving from one position to another position, about 16 meters away, within 8 seconds. Here, the car starts from O and after 2 seconds, it reaches position A, covering a distance of 4 meters from the origin. In the next 2 seconds, it reaches position B, covering a distance of 8 meters from the origin. And in the next 2 seconds, it reaches C, covering a distance of 12 meters from origin. Again, after 2 seconds, it reaches D, covering a distance of 16 meters from the origin. In this case, the car covers a total distance of 16 meters in 8 seconds, with equal interval of 2 seconds. We can conclude that the car had travelled equal distance in equal interval of time. So, this type of motion is known as uniform motion. Another example, consider a car moving from one position to another position about 16 meters away within 8 seconds. Here, the car starts from O. After 2 seconds, it reaches position A, covering a distance of 2 meters from the origin. In the next 2 seconds, it reaches position B, covering a distance of 8 meters from the origin. In the next 2 seconds, it reaches C, covering a distance of 10 meters from the origin. And in the next 2 seconds, it reaches D, covering a distance of 16 meters from the origin. In this case, the car covers a total distance of 16 meters, but the distance covered in each 2 seconds interval is not equal. From this illustration, we can conclude that the car had travelled unequal distance in equal interval of time. So, this type of motion is called non-uniform motion. Here are some examples of uniform motion. A train going along the tracks at steady speed. The hour hand of a clock. It moves with uniform speed, completing a specific distance in an hour. A cooling fan running at a fixed speed. A vibrating spring in a sewing machine. Now, let us have a look at the examples of non-uniform motion. A horse running in a race. A bus on its way through the market. Dragging a box from a path. A man running a 100-meter race. You must have seen that newspapers, magazines presents information in various forms of graph to make it interesting. Similarly, the information about the motion of an object can also be represented in a number of ways. The data of total distance travelled and the time taken for the object to cover it can be recorded in a tabular form. Alternately, it can be represented in a graph. So, a distance time graph is a way to visualize, show how the distance travelled by a moving object changes with time. We will consider 3 cases. First case, when an object moves with uniform speed, it covers equal distances in equal interval of time. So, the distance travelled by the object is directly proportional to the time taken. Thus, the distance time graph of an object in uniform motion is a straight line. The slope of the graph indicates the speed of the object. Greater the slope is, the greater will be the speed. Thus, we can easily compare between 2 objects just by looking at the slopes. Second case, distance time graph for non-uniform speed. When an object moves with non-uniform speed, it covers unequal distances in equal interval of time. Here, the distance travelled by the object is not proportional to the time. Thus, the distance time graph of an object in non-uniform motion is a curved line. Third case, distance time graph for a stationary object. When an object is stationary, it does not change its position. So, the distance remains constant. Thus, the distance time graph for a stationary object will be a straight line parallel to the time axis or the x-axis. So, we can conclude if a graph is a straight line having a slope, then the object is in uniform motion. If the graph is a curved line, then the object is in non-uniform motion. If the graph is a horizontal line parallel to the time axis, then the object is at rest. Now, let us have a glance at the advantages of distance time graphs. The variation of a distance travelled can be seen more easily from a graph than a table. The tabular form gives us information about the distance travelled at a certain point of time. But with the help of the graphs, we can find that distance moved by the object at any point of time. The slope of the distance time graph will give the speed of the object. Let us summarize what we have learned. A body is said to be in uniform motion if it travels equal distance in equal interval of time. A body is said to be in non-uniform motion if it travels unequal distances in equal interval of time. Motion of an object can be presented in pictorial form by their distance time graphs. The distance time graph for the motion of an object moving with a constant speed is a straight line, and the slope of that graph represents the speed. So students, let's wind up today's class. Hope you have enjoyed it. Thank you.